Welcome. I'm Julia Beckering, and welcome to the third evening of the lectures Making Architecture, the series that we are organizing as the chair of Architectural Design and Engineering together with Anarchy. And well, the topic, like previous ones, of course, is about making architecture. So how do you translate an idea, a concept in architecture to a tangible building, so a really realized building? And how does the process of making interfere with the design and concept and development of the concept in itself? So tonight we are very happy to welcome René van Zuuk from René van Zuuk Architects. And we are very happy to welcome Ellen van der Wal from Meccano Architects. And we are very happy because Francine Huben regretfully had to fly to the United States on a short term, we just noted. And we are very happy that Ellen van der Wal, as one of the partner architects from Meccano, wanted to be here and give a lecture about the work. Well, as said, the topic is about how to make architecture, how this really comes into being. And first, the first lecture will be by René van Zuuk. And well, it's nice that both architects sitting here have a connection with Eindhoven. René van Zuuk as having been a student here, as most of you are now. And he has also been professor for a few years at our university. And well, he started off his career with winning a design for a house, Fantasiehuis in Almere. And he really started with really making and building himself the house. So the making process is really into the veins of the work of his office. Yeah, then you can read it also. That's it. And well, what's very nice about the work, and you really have to look at that while he's giving his lecture and also ask questions afterwards about that, is that he's really pioneering with materials and with the process of making. So never happy with the features of the material in itself, but always wanting to transform it, doing experiments with 3D printing, with building himself the biggest foam cutter from the Netherlands, and experimenting with how to really make the projects. Well, he has built a whole range of buildings, from infrastructural buildings, bridges, to small, cozy, nice houses, from sports centers till small objects. So there's a whole variety of work. Afterwards, we'll have a lecture from Ellen van der Wal from Meccano, and well, they are really in contrary to the going against the rules, in the sense that while all the offices in Holland were shrinking and shrinking, Meccano was expanding and expanding, and I just heard that by now they are with 170 persons, so that's a huge office, and they've expanded their work in the last 10 years, more and more also to abroad, working on the, well, recently winning the National Library in New York, and all kind of prestigious projects like the concert hall in Taipei, and in we're working from Taiwan, London, Birmingham Library, but also building in Holland a lot. And that's so nice that Ellen has worked on different projects also in Eindhoven, so you really can go here close by and see the project, so see what actually she's talking about. And well, the office of Mecana always has focused very much on the tangible, the senses, the way material can transmit the feeling of the material. Well, this is the schedule from this night. First of all, René will start, then we have a short break. Afterwards, Ellen is giving a lecture, and after that, we'll have discussion. So, René, the floor is yours.
If you look at the building industry, then you find that the building industry always starts with a raw material. A material which enables you to make anything you want. But that's not what the building industry does. As soon as the building industry gets their hands on a material, they start to make little modules, blocks, profiles, bars, and plates. And if they make their components with those elements, you're bound to have a rectangular component. And in the end, you're bound to have a rectangular building. About 30 years ago, the computer was introduced within architecture. And in the beginning, the computer was a very sophisticated drawing machine. But it didn't take very long before the computer could almost do anything you want. You could make far more than the building industry could cope with. And architects started designing a project like this, but you couldn't really build them. Yes, there are some architects in the world who can build them, but they have budgets which are far beyond the budgets we have to deal with in the Netherlands. If you want to build a building like this, you have to know how the building industry works. This is a singularly curved surface, this is a fold. And you can only make that fold if you don't use any double curved surfaces, but otherwise you run out of budget. The Architectural Institute was one of the first projects for us with a fold. Before that, we made a pavilion where we had a twisted form. We can only make a twisted form because we have folded metal sheeting, and it's very easy to twist that. That's the reason why we could make that building. This is the building which is a little bit more expensive than a barn, but it looks like a pavilion. We used that same system with folding panels in a project in Roosendaal to get a pavilion. And we couldn't make the roof because we made metal sheeting with concrete on top of that, and we could twist that as well. It's not always that you know how the building production technology works or the system works. It doesn't mean that the contractor is also going to use that. We worked with a project where we used a tunneling system. But once you put a tunneling system in a contract, your contractor gets offers from prefab building companies, and they're far lower than you ever could make with your tunneling system. And the funny thing is, we designed the whole thing on a tunneling system, where you have a width and a height which is fixed, and you have a flexibility at the front, and you have a flexibility at the rear of the building. But that doesn't mean that they build it that way. We could make this building because we covered the exterior wall, made the skin with flat panels. Flat panels you could build in the building industry. And we made the stress of the exterior wall by changing the overlap. You have more or less overlap, and that means that you can make a bump in the building. At the moment, we're working on a project where we also use a tunneling system. This is a project in Hilversum. This is the map of Hilversum. This is the hospital in Hilversum. There are 8 blocks on a row. This is our plot. And here we have our street. This is the site. And this building, we got the commission for Block 16 in 2000. Block 16 was built in 2004. Exactly at the same time when we got the commission for this project. This was the first scheme. We always make another model. We make a model and we try to feel what kind of scale the building has to be, what kind of form the building has to be. Our client was a contractor. He just went to the city, he wanted to copy a block like this. And said, okay, I'm going to build a block there, and then I make my money. The city said, oh no, you're not going to do that. You have to make something special. And at that time, they gave our name. They had to work with us. That was a really nice time. We don't have it anymore. The first 20 years, we didn't have anything. We had to do anything to get a job. We just got by telephone. They called us, we didn't have to do anything. Now, since the crisis, that changed. We first investigated on that plot what were the qualities of the plot, and we just put in the infrastructure. And when we put in the infrastructure, we found out that half our plot wasn't even buildable. That is the main sewage line of Hilversum, which is a high pressure line of about 60 centimeters. If you hit that, you'll have dirt around the neighborhood everywhere. That is the high pressure water line from Hilversum. You also don't want to hit that one. I know maybe you remember in Amsterdam they hit one and the whole street was gone. So the only place where we could build the building was on that spot. But our plot was very expensive, and our client needed to have 55 apartments on that plot. We only had 11 stories, and this plot was only 350 square meters. So the only thing we could do is make a building which grew to the top. Our first design was a kind of tornado, a really nice design. And that design lasted till 2018, till the crisis. Our client sold the land to the building society, and the building society wasn't allowed to make expensive houses anymore. So we had to redesign this design and make a brick building. Brick was, after 2008, bricks was the favorable material for every developer. So we designed the bridge with a tunneling system, a tower with a tunneling system, which goes out the further you go up. And this is the final building. 2 weeks ago they started on the site. That's 12 years after we got our first commission. And next week we should have had on Tuesday our first meeting with the contractor. So it takes a long time. If you look at the work of an architect, you find that an architect is not an inventor, but more or less a collector. An architect collects techniques and materials from the building industry. And if he doesn't follow the way the building industry works, the building becomes very expensive. So complexity is not an issue. They don't want that. In 2006, I joined a symposium here at the Technical University of Eindhoven. And at that time I told my audience that maybe in the future we're going to print buildings. And if you print buildings, the architecture and the way the architects work will change dramatically. Complexity for printing, complexity is not an issue. The only thing a printer wants to know, do I have to put a dot here, or don't I? When I had a lecture, most of the people were laughing. And at the end of the lecture, most of the people came to me and said that is not going to happen in 100 years. It took only 2 years since an Italian entrepreneur, Enrico D, made a printer which could print 3 by 3 by 3 meters. And a few years later, he had a printer which could print 6 by 6 by 6 meters. And that's already a small house. Each machine worked with a layering method. You put a layer of dust, you put a resin, print a resin on top of that, and then you put a new layer of dust, and you print it again. And that way all the printed areas glue together, and you can take out the dust and you have an element like this. The sprinter is very precise. It's also very slow. And is very flexible. So you don't need support material. This support material is the dust. Nowadays, there are printers which go much faster. They have one here at Technical University. I think they're still experimenting with it. But in China, they already have a printer, and they claim they can print a house in one day. My contract ended here at the Technical University as a professor in 2010. I had an exhibition, and I asked my students, could you make a sequence for me, starting with a normal, traditional house, and show what would happen if you use 3D printing? And they started with a house, number one, and the first thing you're probably going to print is the concrete, the structure. But if you print the structure of a house, and the complexity is not a problem for the printer, you're not going to make a straight wall, angle between the wall and the ceiling. You're going to make a curve. That takes less material and is stronger. So, in the future, probably not the architects want to have fluid architecture, but the economy wants. This is just cheaper than a straight wall. A curved wall is a more stable wall than a straight wall. So, it would be stupid to make straight walls in the future. The second step is what happens if your printer can print not only concrete, but also insulation and the exterior wall. If your printer can do that, then you can print already a whole house. Number 4, what happens if you build a house in Africa? You don't have to bring all the filler and the binder to your workplace. You can just have the binder and use the soil which is there, dig a hole, and print with the material you're building. And the last two, yes, the house has to be self-supporting, and yes, maybe we have mobile houses in the future. It sounds a little bit strange that we pump every day to keep half the home dry. Why don't we use that now? Why can't we make houses in the water? This was the final model we had after that session. And we really wanted to have the evolution of man, starting with the ape and having our building. And people ask me often like, okay, do you think the house in the future will look like this? And to be honest, I don't. If you look at all the developments in the building industry, they never lead to another kind of architecture. They always lead to something we already know, but in another material. Our wooden windowsills are changed by aluminum ones and wood, and plastic. We have our wooden sheeting is now made to meet. And yes, when you ask the firm of Trustfund, they can give you stone plastic laminate. So yes, maybe the evolution goes in a whole different way. And this will be the house of the future. It looks like a wooden house, but it's all fake. And that's exactly what the Chinese companies do. That's their house. They can print in one day. So they're making a kind of American mansion. Why would you print a house like this with this quality and with electricity like this if the traditional building industry can do it much better? So why would you do that? I don't think it's useless. But what happens if somebody asks you to build something like this? This is impossible to do with the rectangular house of the building industry. It will cost you a fortune. And this building site is a contractor's nightmare. You don't want it. So, it is very important, if you want to use a 3D printer, also change the architecture, but otherwise it's useless. I left, or my contract finished in 2010, and at that time I went back to the office of a full-time architect. And when I was there, I thought, okay, I'm going to use the stuff I learned from 3D printing. And we were really eager to do that. And we have a 3D printer at the office. But after a few weeks, I realized that it would take a long time before we could implement that. Like I said, the first thing you're probably going to create is the concrete. But you can have a free-forming concrete, but then you have to plaster your insulation on top of that, which are just rectangular panels. And you need to sheet them at the back of that, which are also rectangular panels. And so that doesn't work. So we look for another system. We look for another technique we can use. And the technique we found, we don't have the biggest printer like a foam cutter. We have a very small one. We found that the best technique is cutting foam with a hot wire, with a computer-guided hot wire. You can make almost any foam, and you use the foam as a primary building material. Which means if you clad it on the side, if you put wood on two sides, you have a sandwich panel. And that one's very strong. You can make spans of 10, 15 meters if you need. You can plaster it, and then you have a fire resistance of 2 hours. Or you can use hot spray. Or you can make, these letters in Amsterdam are just EPS foam with hot spray on top of that. So you can make very sharp products with that. Or you can spray it with concrete. And have elephants like these, which have EPS inside them. And they're already now there for 50 years. So, if you look at the hot wire cutter, it normally cuts elements like this. It is mainly used in the advertising industry. But you can also use it to pre-form elements which you mill later. That's what they do with yachts. You cut the big foam out with foam cutter, and then you mill it. We're not interested in that. We just want to cut the foam with a hot wire, because that gives the best result and gives the fastest result. We built this type of hot wire cutter. That is a very small one. We built a hot wire cutter at the office to make models, and just to see how you can manipulate your elements to build something. And later, they already have machines, bigger machines in the industry. But later you can work with that. But you first have to understand how the system works. So, we started cutting, and the first thing we cut was the dirt. And this one is cut in 2 directions. It's cut in this way, and cut in the opposite way. And if you glue them together, you get a dirt like this. And we were really pleased. It was actually looked very good. But when I saw the amount of garbage we had from this cutting system, I was shocked. We actually only used 15 to 10% of the block. And actually we were not producing our faults, but actually we were producing rubbish, waste. And that's exactly what the studio Hyperbody in Delft did when they cut this one. This is only the half of the garbage they got out of it. So if you want to have a sustainable technique for the future, you can't have 85–90% garbage. You need to have a system where you can actually profitably cut without any garbage. So we looked for a project where we could use. The second thing we did at that time was, okay, we're going to look for competitions. Because when we start competitions, we can, if we win, we can build something. And that's the best thing. You need to build something to show that it is possible. This is a competition in Almere. It was the first competition we entered. And this is called the Puncheria. And they wanted to have special locations with special functions. And we looked, what do we miss in Almere? 200,000 people, what don't we have? Actually, we don't have a church. We don't have any place to contemplate in the city. So what we did, we designed a chapel. And we designed this chapel with foam and wooden scales, which could be nested. To do that, you need an unrolled surface. That means that it has to be a perfect single curved surface, or otherwise you can't have the wood on top of it. Now this was the church. We won that competition, or we were one of the winners. And after 2 years, next Friday, that's the first meeting we're going to have. What are they going to build it, or what are they going to do with it? I don't know yet. This is the nesting of the elements. But if you look at the nesting of the elements, it's not perfect. And you need to cut it several times to get your block, which makes it very unprecise. So the next thing we wanted to do was find a technique where we could cut without any waste, and only cut it once. And when I thought about that, I remember that when I was young, we had a box where you could put boxes on top of each other. And the funny thing is, if you cut the inside of box number 10, you also cut the outside of box number 9. Which means you only need half your cutting length. That saves you a huge amount of time, but you also don't have any waste. So the next thing what you have is, instead of having the block where we cut out the form of the arch, we don't have any waste. We actually, our primary block is getting 10 times as big as the original volume. So you can make really big projects with this. So we were looking at competition number 2. And that competition was in Zuuk, the North Holland. This is the Frauenborg Castle, which is a national monument. And that castle has all kinds of rooms in it. They have a red and a green room. And what we said, okay, maybe it's good when we have an additional room, which is a copper room, outside in the garden. And we made the base of the copper room a square, and we made the top the silhouette of the pavilion. We made a grasshopper script, and we scripted it so we could make a form. And we just used a block of 4.5 meter and 50 centimeters high. And we started cutting, and we started building. The skylight, which is on top, has a part you don't use, and we use that as a table. And then it builds up like this. And it means that you can have a pavilion like this, coated with a copper coating. This is the castle. And the inside, you have the skylight, and that part comes out of the skylight. So you don't actually lose any material. We cut that block on our machine in our office. Now we have to go to the industry and see if they could cut that. If we could cut it in real size. This is a modification we made on the machine to cope with the very strong angles we made with the machine. So we had to find a company who would also want to have make a modification on their machines. And we found that company, which is called Dutch BPS in Ireland. And they can cut blocks from 5 meter by 2.5 meter by 2 meter thick. Just one block of foam they cut on the machine. This is what you have. The nice thing is they actually use the same software we use. So we could actually give them a G code. And they just have to put it in their machine and just make it a little bit bigger. Now we did. And the rest works exactly the same as we did before. And you have the cuts. And then you can peel it up and make your pavilion. And foam is the base material where you make it from. Then we sprayed it, or they sprayed it, with hot sprays, and that gives you a 3 millimeter thick layer of plastic on top of the foam. And afterwards they spray it with a copper coating. There's a company in Holland who makes copper coatings, which exists for 95% of copper and 5% polyester. If you spray your element with it and you rub it off later on with a steel sponge, the copper comes to the surface. And it's a real copper building now. The foundation is very easy. The foundation is 4.5 by 4.5 meter. We use the anchors from Sweden to hold it on its place. And then we start building. And the pavilion is 4 meters high, 4.5 meters by 4.5 meters. And everyone comes to it and takes on it. Is this copper? No, it's foam. It's fake. Having done the first project, we entered competition number 3. And this was a competition in London for a pavilion of the sky. And when I read that it was going to be a pavilion of the sky, I thought immediately at the drawing of Escher, devils and angels. And we wanted to make a pavilion which was from the Bible book Revelations, and when the archangel Gabriel was fighting back the devils back there. So I thought maybe it's good to have the columns at the base of the building, the devils at the top, the angels. This is a plate what we started with. Again, a rectangular plate. And this is what you get out of it if you just build it up. And if you look at the top, you see that we have angel skylights and devil columns. And 2 of the devils didn't make it too early yet, and that gave us an open space in the pavilion. And those are the devils, and as raised there comes rain. Your harm comes from there. We didn't win. We asked the jury why we didn't win. They said it was too serious. It should be an enjoyable pavilion. That's probably also the reason why we didn't win our third competition. That was in Governor's Island in New York. And that was about the waste you have with EPS. EPS is a very difficult material. When it comes to the environment, it will stay there for 100 years. It won't rot. That makes it very bad for packing industry, and makes it all very bad for the food industry. But it makes it, of course, a very good building material. Because the last thing you want to have is a building that rots. So you actually want to have it last for 100 years. We told that we're going to make a pavilion in the form of an iceberg. Because actually they only reuse now 10% of the foam. So that's the tip of the iceberg. 90% is underwater, and actually 90% of the EPS is probably also in the ocean. And that is wasted, so you don't want that. So again, we started with rectangular blocks, and now we cut it into 4 pieces. And we rotated those pieces, so we would have a form, which is kind of free form, what you have with an iceberg. Unless there is layering again, and if you put the layers on, you get a building like this. 6 meters high, 18 by 7.5 meters. And if you clad it, plaster it, you get a model like this. Everything comes from the system. You may think we cut in the door, and we just cut off a piece of the element to make a door. But that door is in the system. That's the door. That's your straight angle. Because you fold it out, you get the door for free. Beginning of this year, we entered a competition number 5, for refugees. Make housing for them. Refugees at the moment is quite a big problem. People living in a war zone coming back to the rest of the world. Most of those people live in tents in Turkey, Lebanon, or Jordania. Some of them come to Europe, and if they come to Brussels, they also have to live in a tent. If you live in a tent, you have a problem, because the tent gets cold in the winter. You can't stay there. But if you come to Holland, you have at least your own private bed together with 3 other people in a sport facility. the co-op really wants to house people like this. But the problem is, they don't know how many people are coming. And they don't know how long they will stay. So in 2013, they were demolishing all those houses. And if you do that, you get really a lot of waste. And that's something you don't want. So we suggested to them, just make a tent. Make a foam building with a tent around it. The nice thing about a tent is that you separate the materials. You can use the foam afterwards, you can reuse the foam very easily. And you have a tent which saves, makes it watertight and makes it livable. We designed a module for that. And that module is 2.40 meters by 4.80 meters by 1 meter high. And that means you can easily bring it on a truck. And you can also have a huge warehouse where all those blocks are in. We designed a corner element and we designed a middle element. And you can join the corner elements together and you can have a house for a small family. 24 square meters. You have to think that every refugee in Holland gets 5 square meters. So 24 square meters is a lot of space they have. You can have a double house with the element in the middle, which is 17.5 square meters. That's for 2 couples. And you can have one with houses in the middle. This competition, 366 people entered. 12 are selected now for the second stage. And in a month we have to submit the second stage for this competition. This is the interior. 2 doors and a very simple interior. If you look at the houses, you can put it in the field and have a kind of tent camp. It's not the perfect way, but it's a very good solution for a very short time. And those buildings are so cheap that you can actually leave them for a year and still be financially make. You can demolish them. You can also use those elements to make a small house, and they make beautiful houses. And they look like this. In 2008, like I told you, the first 20 years of the office was very easy to get work. After 2008, 2010, it became more and more difficult. We had a small office with a really wide range of projects, which means that we don't have any experience in anything, according to people who make the rules. And we found ourselves making more and more infrastructure work. Our first infrastructure work was a log house in Groningen. It also smashed. And from that client, that was somebody who worked with the township and later worked with the contractor, we got our second commission for a log house. And this house, the log house is in René. And the strange thing about the log houses, they didn't want only a log house, they also wanted to have people have a place that they can look at the log house. And they suggested do it a little bit out there. We told them, you don't have to do it there. Why don't you do it on top of the roof? This is where the guard is sitting, looking. That's where the public is. Those are toilets. And the public can be on the roof and have even a better view than the people from the log house. When we got a commission on Block 16, we also got a commission for a pier and a bridge. The pier was only built till here. They didn't know what to do with the rest of the pier. The problem was on there, they made the land. We made the land from the sea. And what they do, they made the lake afterwards to pump up sand to fill the land. But they left the pump on that spot. And there was a gap of 20 meters deep, which made it very expensive to build something there. 3 years ago, they made a museum and then they needed a pier for their boats. So that's why we got the commission. And when we got the commission, we asked urban designer, so what do you want? And he said, we will have to know to have something special on the corner, something with a light. So why don't we make a tail, not called tail light at the end? And make it red on one side, green on the other side, and make it beige. And this is now a really hot spot in the mirror. The youth is sitting there every night. It's sitting so long that they now have to shut it down in the evening. After 11 o'clock, you're not allowed to come there anymore. At night, it's a beacon. It's green and white at the top and red at the other side. At that time, we also got a commission, and that's in 2000, we got a commission for a bridge. And when I asked René what was the idea of the bridge, he said, I want to have a bridge which is neutral, which doesn't favor one side above the other. We designed that building, Close Kind designed that building, but we're not allowed to have a bridge like the Erasmus Bridge, where we want one-sided column and a fishing line and pulling it to the other side. So we decided to make a bridge built by 5 columns. 2 columns on the land and 2 in the middle. And maybe it looks a little bit strange, but the first column is carrying the second column, and the second column is carrying the third one. And that makes it, if you mirror that, you have a bridge. The only problem with the bridge is, always you design a bridge which is not between 1 and 3 hertz. Because when an army walks over it, it will vibrate, and that's not allowed. Our bridge was on 2, which meant it was just at 1 spot. So we made an additional stress structure under it, so we could squeeze up the frequency to 5. And then it was okay. The city of Almere, the bridge is next to a harbor. The city of Almere wanted to have a marina there. And if you're all over the world, most visual elements are amassed on the same boat. And that's what our developer from this building told their clients. If you buy an apartment, then you can have the same boat in the harbor. The only irony was they never could get there, because our bridge was in front of it. So we put the mast of those sailing boats on top of the bridge, and at least gave the appearance that it was a harbor. Recently, I saw our bridge from 2002. Recently, I saw the bridge in Brisbane, and I'm really glad they used that same system. 2 years ago, we got another question from our friend from the Log House. Another competition. And this is a competition for 2 bridges. Bridges in Oslo. There's a project which is called the Blauwe Os, running from Zeeland to Groningen. And European money puts a lot of money in that. European community puts a lot of money in that. So tourism kind of prospers. And they are making waterways all the way. Oslo wants to revitalize its canal and make bridges in it, so you can get with your boat on the canal. This is the Beierstraat, and this is the Koningsstraat. The other one was the Koningsstraat. The ambition document told us that we had to make a drawbridge, which is actually a traditional Dutch bridge. But if you look at the bridge, they more or less all look the same, so we didn't like it that much. If you look at the structure of the technique of that bridge, then that bridge works very well because everything is parallel. This one is parallel to that one, and that one is parallel to that one. And if you open it, all those lines will stay parallel. And that means that it is in a perfect balance. And you need to have it in a perfect balance because you have an engine there with a rack, and the rack can't have that much tension on it. So it has to be in balance because the forces are very small. That's how they did it 30, 40 years ago. And they still do it that way. But you don't have to do it that way. Most of the bridges are now controlled by hydraulic cylinders. And it means you can push them up. And the nice thing about the cylinders is that you can make it any size you want. So the force is not an issue anymore. So we designed a bridge where it isn't parallel, but where it is a trapezium. And if it goes up, the lines don't stay parallel, but they are parallel in the end. That means that you have a balance in the end, but you don't have a balance in the beginning. But if you realize that a traditional bridge needs a weight to keep the bridge down, then it's even easier to make it this way. So we made a bridge where you have asymmetrical, we have trapezium form in it. This is the model we gave. We gave actually our pine mirror. So we made half the bridge. With the mirror we had a whole bridge. And they're also building in two halves. And at the moment they're building them. This is, by the way, the Weyer Street. We have like two bridges, but we want to make it a little bit different. We have a lot of space in this location, so we put the harmonics called in Dutch. We put the harmonic to the outside, and the other bridge we put the harmonic to the inside. And this is the steel work they're working on. And this is half the bridge. And that bridge was so big that the steel company couldn't hardly make it in its own workshop. Because that was not the biggest problem. The biggest problem was find the road to the building site. How do you get that big element to the water? This is how to put it in. The last project I'm going to show you is another bridge, another competition we entered last year. 127 people entered. It was an open competition. 5 people went through the second round, and eventually we were the lucky ones to win the competition. This is a bridge in Dordrecht. This is the city of Dordrecht. There is our bridge. If you look at the side, the bridge is spanning from this side to there. It's about 130 meters. If you look at the side, then the side is the junction between the scale of the region and the scale of the city. And if you look at the region, they have 4 major bridges. And they're all in common that they're white at the top, the industrial bridges, but the deck is grey. So it would be very logical to make a bridge where the top is white or silver, and the deck will be dark grey. If you look at the bridges in the city, you see that they have a huge variety of bridges. It's beautiful. They have really industrial bridges with really nice technique, building technique, but all really nice moving technique. They have all kinds of bridges. And they're all dark or white. They don't have another color. They have moving bridges, rotating bridges, drawbridges, double drawbridges, and bridges for pistons. That was our location. And if you look at the architecture around that location, you'll see that also the architecture is technical and architectural. They have a kind of industrial heritage they want to keep. And all these big elements are staying there on that side and give the whole thing just an atmosphere of the industry that used to be there. So when we thought about what kind of bridge would be most suitable on that location, then it would be a technical bridge. This is a span of 130 meters. The opening part had to be 50 meters. And that's quite big. We were allowed to make 2 kinds of bridges. A lifting bridge, or a bridge, a bascule bridge, or a drawbridge. If we look at all the urban plans of the urban designers, it's a drawbridge. And if you look at the drawbridge, that span is 50 meters, and that is also 50 meters, and you realize that this log is going to be really heavy, and you need a huge weight to compensate that. So that was not a good choice. So we decided to make it a screw bridge. We had a place span for 50 meters. If you have a screw bridge, your arm is about a quarter, which means that's 12.5 meters. But that bridge was only 5 meters above the water, which means that the weight would drop into the water, which was not acceptable for anybody. So you can make a saddle, but a saddle is a very expensive and heavy element. And we really didn't want to have in the water a huge concrete block in the middle of the bridge, in the middle of the water. So we decided to make a small arm. We calculated this bridge, and we found out that if you make your ballast like this, you need a counterweight of 1,200 tons. But we didn't have enough space to make 1,200 tons, so that wasn't possible. So we decided to make the bridge in the form of a mast. Our ballast is in a mast. When it goes up, the ballast stays straight. So the bridge goes up, and your ballast actually goes with your bridge. And we needed a knick, because otherwise the ballast mast would go through the axe. This is the event bridge we designed. It has four hinges, 4 axes, instead of one axis with a normal bridge. It has 2 fixed axes, that one and that one. And those 2 are flexible axes. They will move down. And if you look at the directions, you see that this is a curve this way, that's a curve that way. And that means, again, we have a bridge which doesn't run parallel. So actually what the bridge does is that it flips down. We couldn't get the weight, we went down from 1,200 tons to 600 tons. And it's 30 meters high. And we were a little bit anxious. If it flips 30 meters high, 600 tons, that would be really difficult to control. But when we drew in the axe, with the arm on the axe and the hydraulic cylinder, we found out that when the bridge is pulling down maximum, the arm is also in a maximum. So in the end, actually the bridge walks smoother than it would do without a moving ballast. This is the bridge we designed. And we designed it like a hot knife, like a Swiss Army knife. You can fold it and fold it out, and it fits. And this is the final bridge. And to conclude, I want to show you a little movie. It's only 1 minute. So you can see the movement of the bridge, because it's kind of ballet.
Well, yeah, my name is Alice Noel. I'm from Meccano, and I'd like to tell you a little bit about making architecture. At least that's what she had asked me to do so. Well, probably a lot of you know our office. We're based in Delft, and like she was saying, we're already with 170 people, so it's quite a lot. We do a lot of this way, international work, of course. But today I'm going to show you a couple of projects from the Netherlands. One very close by, which is the Sporthogeschool here in Eindhoven. This is our team. Well, probably not all are there, but we are doing architecture, urban design, landscape design, interior and restoration and renovation. And we work very interdisciplinary. And that's the way we believe that's how we should do architecture.
Excuse me, could you turn on your microphone, please? Because I think it's not turned on.
Is it I have to half undress now.
We won't do it.
It is on. So basic?
Yeah.
Okay. It's okay? Alright. This is actually what I just said. We're doing urban design interiors. Lately we do a lot of care also, hospital projects, and that's also one of the projects I would like to show to you. Of course, this is the building that a lot of people know, and maybe the last days and last months, I would say there's a lot being published about this building. This is the building I would like to start the lecture with. It just opened in February. In December there was a soft opening, so since December people are actually staying in the hotel. I would like to explain to you about the Hilton project, then a little bit about Urgest, not the whole project, but about the facade, because it's also a composite facade. And then after that, the medical project I was telling you about in Saint-Lom. This I would like to talk to you about because it's a lean building, and maybe you heard about it from the automobile industry, but I will explain how to make a lean hospital. And then the last project is the one sort of around the corner, the Sporthogeschool. First, of course, the Hilton. This is the complete project. As you can see here in the back, you can see this is the old existing Hilton, and it will be demolished. I think René also explained a little bit about the one thing about making architecture that's maybe the thing you need most, that is patience. This is my daughter. She's 12 years old now. And actually when I started the project, she was not even close by. So it took 16 years to build, to design this project. And it's of course not the design, it took so long, but it's about the whole process. So it's about patience, making architecture. She's actually here in this corner, in these windows. I'll explain you about it. In 1999 I started. It was sort of my first project as a project leader, so I was very proud of it, but then, it somehow stopped and it continued and it stopped again. This is this building I was just showing you a picture, this existing Hilton Hotel, and the first thing they asked us, could you make an extension of that building? It's a very ugly building. So it was a pity, but we called it the Beauty and the Beast, and then it became nice again. This is Plaza, and this is the World Trade Center, the offices. This is the Sheraton Hotel. This is the way you go to drop people off and to get people from the airport. And the A4 is somewhere here. So it's actually a very important point for Schiphol because it's the main entrance towards Plaza. In 2000 then we finished the design of our first proposal, There's wings, and this is the existing hotel. There was this gateway building designed by Benton Crowell on top of this highway. But then, we designed it all the way to tender documents. It was already on the market. Ballas Nederland was supposed to build it, and then suddenly it was 9/11, and then of course after that the whole hotel industry collapsed, and there were no more developments in this sector for years. But then in 2005, Schiphol took over, and then it became not a Hilton project anymore, but a Schiphol project as a developer. Of course, Hilton still operated with it. We made then, in this picture, it became 100,000 square meters because it became twice as big, but also a huge conference area in the back. And then, of course, it became 2008, and there was another crisis, the financial crisis. So again, the project stopped. But you can see here the first atrium models coming up. And Hilton in the beginning didn't want an atrium model, but later on they changed their minds, and especially on this side, it became a really nice internal atmosphere. I will show you later. Then in 2010, the project as it is now really started. And as you can see here, the existing Hilton is gone in our designs. It should stay there till the opening because they did it from commercial reasons. They don't want to take the name out of here, let's say. So it's, I don't know what I'm doing, but I'm making noise anyway. If it becomes too irritating, tell me. We designed the hotel in this sort of tower, and in the low part was the conference center. And we designed it really in the corner of this elevated highway. We turned it a little bit, so it became a new direction, also to this Evert van Beekstad, where there's a lot of new developments from Schiphol. And also by turning it, and of course the edges are a little bit roundish, by turning it, it becomes also very much important for Schiphol, but it became a landmark in this. In this main entrance route towards Plaza. So we kept the facade in the same colors, let's say, as the rest of Schiphol, which is white, grey, sometimes a little bit black. So we made it very special in shape and in facade, I will tell you about it. But in colors we kept the same tones. You can see a render of the design, and there you can also see it's an atrium model. It means that this is the floor plan. Two sides of the two parts of the rooms are looking inside this atrium, and three sides actually looking outside. And on the top floors, this was the first picture was taken where my daughter was there. It has also rooms, an executive lounge on that level. Here you can see the conference areas and this rooms looking into the atrium. This is the ground floor, all the grey back of house, and so it's actually a whole machine where flows of linen and food and waste cannot cross each other, so that's why we have a whole system of corridors around the lobby, and then actually sort of the first building where there's actually a function in the plinth towards the boulevard. All the rest of this boulevard has only parking in its plinth. So it starts, this is sort of the beginning of a new introduction on this side where all the offices have more functions in the plinth. On the first floor, there's all the purple are meeting rooms, and this is the spa. This is the level where you can actually come from the airport, from your airplane, let's say indoors, all the way with this traverse into the lobby of the hotel, so you don't need to go outside. Executive floors with executive lounge. And then something, when I was preparing this lecture, I was thinking what is very much important about this project, about having a lot of patience, is also about communication. This is a building, and René was also telling me in the beginning of this lecture, with roundish shapes, and it has also this section through here, which is together with roundish shapes quite complicated to draw actually, and of course to build. And therefore we started to draw in 3D in the Revit model for our office. This was the first project we did draw in Revit together with all the other disciplines. We did draw 3D dimensional, but never together. But this was the first project, and we used this render also as a communication drawing, but it's actually from the more technical drawing, which is this one. And this is in working together with Gerrit as designing all the plans and systems for the building, and together also with AT, who designed, of course, the many columns underneath the building. Yeah, this is a way of making architecture in a very technical way. In the beginning we had 1,000 clashes because everything was not really fitting, but now of course in the end everything was solved, and it's very nice that we could actually have this clash control as a model. And then about the skin. The shape of the building is of course roundish, a little bit dynamic in this corner of this highway, and how to get from sort of idea, something with a snake skin, diagonal lines, how to get it to a serious facade, which is also, well, there's no rain inside, there's no sound inside. In Schiphol we have a big problem with sound, of course, and all those matters from this first ideas. And this is actually the first render we did. It's not a render, by the way, it's a Photoshop, so it's just an idea, first idea, into realization. We started from this idea with layering the facade. So the first layer we designed was, of course, the windows of each room. Each room needed to have 2 or 3 diamond-shaped glass windows. Then on top of that, we had a sandwich panel, composite panel with a dark color, just the color, like the color of the glass. Therefore, you would never see this sort of regular pattern anymore. You would sort of combine it with the darker panels and then it becomes another pattern. And the last layer is the layer of lines and white panels on top of it. This is the way then how it came out of the computer with renderings, and we played with the system. And here you can see the rooms. Hilton was first, of course, a little bit scared because we couldn't hide up. We have always windows like this, and now windows like that. Is it possible? And finally, we got to convince them, and it's quite nice. Now they're really happy because it's something really special for the hotel. And then, of course, once you start drawing it, we did tender this in a separate tender. So we had a tender for the building and we had a separate tender for the facade. So we worked closely together with the supplier of the facade. And there, of course, we did a lot of testing, not only technical testing, but of course also the aesthetic testing. So here you can see that some of these seams are not the way we would like to see them, so we start testing over and over again. Of course, testing of the colors, and slowly we're getting into realization. And here you can see the difference between the inner facade element and of course the outside cladding, which gives a totally different look to the building. Here you can see perfectly each room with its own windows, let's say. Alright, now I have to switch. So we have it's a little movie of during the construction. It's quite nice to see because this is a nice, interesting facade moment in the building, in building of course. because this is the part where it's finished, and then around the corner, well, you have fireplace. This is the Sheraton, this is the World Trade Center. You can actually see this pattern of the inner facade. It's actually, all this part is straight, although in the end it's mounted slightly curved, but it's straight. And the only thing which is curved are these two panels. And these are the only ones who actually have curved glass. And you can imagine when you make diagonals in combination with something which is curved, but this in the end all the patterns are straight, you end up with a lot of sort of some millimeters difference. So that it was quite a hassle to really mount those diamond shaped panels in the right order. But in the end, with all this computer modeling, it seems always very high tech, but in the end it's just building and with a screwdriver and sand. I'm not going to play the whole movie because there's too little time. Sorry about that. So this is how the building looks now when it's finished. This is the internal facade with all the diamond windows where there's this big atrium. I talked to you about the traverse, which is connecting actually the airplanes, the terminals towards the Hilton. And this is where Benton Crowell meets Meccano. And so the ceiling is continuous from there, traverse level and the floors, and there it starts to have the new facade. And then we have the big atrium, and maybe some of you already visited the building, and this is something you cannot show on pictures and drawings, but I think that making architecture is really about making good acoustics. When you come in here, you have this huge view, and then the atmosphere is quite humane and nice because of good acoustics. So it's always these kind of projects about working together with other disciplines and other engineers to make this building work. Another discipline we used a lot, we worked closely together, is our lighting advisor. And as you can see, every little golden stripe here has a light in it, shining upwards. And in the night time also the atrium gets, the glass in the roof gets really lit beautifully. And then there was the opening after 16 years, I'm just quite happy. And this was the looking up at that moment. It was a really nice moment. The new project I would like to explain is not the whole project I was just saying, but about the facade, because this is a composite facade, and the Hilton was the first project we did with a composite facade. And it's a pity in architecture that you do all those projects. They're always different, and you can never improve your own idea. So here we used the same material, but we did it again, of course, in a totally different way. This was a competition picture, and once we got to really go, this is the model we made in competition, and it was in 2012, and the funny thing is now this building is exactly the same as we proposed 4 years ago, and what you actually do all those 4 years long is proving that it actually works. So it's not designing actually anymore, it's proving that it works all the time. So also about the facade. We said in the beginning what would be nice to have those facade elements a little bit tilted or leaning backwards, or also in a horizontal way. And you can see that very much, very good here. And it reflects the light in a different way. It's a very, it also helps in securing the building. This building is of course full of, it's just, so it's just this part of the European, it's, you have Europol and just. It's a highly secured building, and by making this glass in a different way, it helps also ear dropping, to prevent ear dropping. This is the way we draw in the beginning the details. It's done by hand, but while this whole project is of course again made in Revit, the detailing was in handmade. And that has also a reason, because we also asked the contractor, which was selected in the normal tender procedure after STEC, but we asked him to help us designing the facade. Because also we learned from Hilton that they have designing this facade is a sort of special thing, and they could help us with it. We thought that it would be a good idea to have those elements in one element, so slightly different than we did it in Hilton. So we put it out on the market, and then the market said, no, we do it again as Hilton. So we again make an inner facade element, and we put the composite on top of that. So they did it, detailing it in a totally different way. Yeah, and of course the detailing, the aesthetics and the performance of the facade should stay the same. So for instance, this is drawing we made about all the seams, where they should go and where they shouldn't go. And this is exactly how they made it in the end. They just did it in a different way. So we did a lot of mock-ups, of course, to test it in the real. And what is really beautiful here is that this composite material is perfectly smooth, where in Hilton you can still see that it's sort of handmade work. So it's improving also in the industry. Here you can see a panel, which is, we call it the crown. So it has these huge elements, which are really so small in size. Yeah, this is how it looks like now, just. So it will be finished in December. These pictures are made last Monday. And to be honest, also here we have to keep on going and talking, because what happens on this facade is, I can tell it to you now, is that the whole outside facade, so the white part, is shifted 11 millimeters from the black part. So that means in the end the difference between what we designed or what it should be is at some points more than 2 centimeters, so that you could actually see. So, but what needs to be done there is that all this facade which was mounted till here has to come off, because everything is connected to each other. Anyway, we have a big discussions about that, of course, today. But that's what making architecture is also about, having discussions. Then the medical center in Zuuk. And then again, a competition. I think René mentioned the word competition a lot. Well, I do the same. That's also making architecture a lot of competitions. This is in Zuuk. And when we started, we said, okay, the most important thing in an hospital is to design for patients, of course, because we also design for employees, and also very important for the whole city, and the city with everybody living there. I have to apologize because this part of the lecture is, I will keep on talking in English, but a lot of words are in Dutch, sorry for that. The urban plan we received, where we started off, was to have a hospital on this side. This is the A7, so it's a highway. So people drive here 100 or slowing down a little bit to 80. But the hospital was next to the highway. And then you have 2 parking buildings close to where people actually live. So we said, okay, if you want to design a hospital for your city, you should at least switch it, turn it around. That was easier said than done, but in the end we managed to do so, to have the parking buildings on the side of the highway and have the hospital also in a different shape, more welcoming and opening up towards the city and the city center. So always discussing the urban setting is also a very important thing. That's where it all starts, how the connection with the city is. So it's an open square. There's only one way of looking at a building, finding your entrance. Very clear. Finding your orientation, keeping your orientation is very important in the hospital when normally you're not the happiest person when you have to go here. So stress is something that doesn't help your orientation. So therefore it should be as simple as possible. Zuuk designed the City Hall in Zaandam, and he was inspired by the Zaanse huisjes. So we made our inspiration in the industrial heritage of Zaandam. So we made a brick building with white volume on top. I never showed this before, but I thought now it's about making architecture. This is the sketch, and I know I never showed it before. This is a very ugly sketch. But the funny thing is, it is actually totally what is in the end being realized. At least I can see that in my own sketch. That's what I meant. You can see here 3 layers, because these little things are floors. 3 layers of brick building, and this part is a little bit this part has a balcony. It's for the people who stay in this high part, and this is a bit white. The blue sky, can you see? Well, the funny part is 3 years later, it is how we designed it in the beginning. Of course, it all starts again also with finding the right brick, and this is a beautiful brick. It's Voltasan brick, and because it's a very expensive brick, we have to turn it on its side, so then you need at least less bricks. But I didn't want to talk so much about the facade in this project, but more about how the project was organized in the inside. By turning this hospital not on this position but on this position, you could actually enter in the middle of the building, which is for a hospital quite nice because it's 40,000 square meters, so then at least you don't have to walk the whole length of the hospital. So this is what we did. We come in the center of the hospital, we enter, and then from here you only go left or you go right. There are not much more choices. And then on the end of this red main street, let's say, there are 2 important patios to help again your orientation. So it should be as simple and your orientation is very, very important. What also helps in the orientation is this red arrow, this street. It's in 2 layers. We give it a very different shape. So every time you're from your doctor, you find your way back to the street, and you know, not only because of its size or route, but also because of its architecture, you know, I'm back in the street, and I find myself my way back into the main entrance. This is our competition image of this street, and yeah, the materialization, it all got sort of the same routes. It only was shrunk a little bit because this is quite a big entrance hall for a sort of still not so big hospital. So it was actually a good thing to do, and of course it saved money. Again, here the 2 elevators. This is the public elevators. Next to it we have that elevators, so it's all very compact and its size. So the orientation, again, is an important thing. Shape, the 2 patios, and the street also is there to show different centers. It's sort of little hospitals within the hospital, and they can present themselves next in the street. They're still renders, and on the street we make this graphics, so it's 90 meters long, 3 layers high. We make graphics all along. And it's very, in the end, I think it becomes a really special hospital. This is how it looks now. So the graphics will be as wallpaper on this wall, so the blue will be gone. But the beautiful light from above, of course, will stay. And you can see the light already coming in a nice way. But that's maybe the easy part, to design this street. But now, how to design and make this functional, and that you can orientate yourself very well, and that it's workable for doctors, and that the whole system facilitates the best care. How we did that? We did that together with the hospital. They wanted to be the first lean hospital in the Netherlands. Lean is a methodology which comes from the United States, from Toyota, and lean in that industry was eliminating as much waste as possible. So how to start to design and to fabricate a car in a very efficient way. This is how they look to the care system the same. So they want to do it in the most efficient way, only to serve the patient the best. So for instance, waste, to eliminate waste is also eliminate waiting space for patients, or defining short routes, and all these kind of things. Not having, for instance, that if you are a patient, you have to see Dr. 1 and then go to radiology, then make an appointment, then go see another doctor. You may sometimes have 4 or 3 different things to do in one day. This hospital wants to organize it in a different way. The patients are staying in one place, and the doctors and the secretaries and the nurse are coming to the patients. So that's also a lean way of thinking. So in the competition stage, we said we have public on the ground floor along the street, and in the top floors we have more private, so it's the rooms where patients stay. These are connected to gardens and balconies, and the public, so it's polyclinics, I don't know, is that the English word? The polyclinic is connected to the street. If you think in this lean way of using lean as a method, you could say this is a flow of patients. And this is a flow of patients. And if you forget about building, you have this flow of patients. This is where people stay. This is where people just go for 1 appointment or 2 appointments with the doctor, but after that they go home. Then if you add 2 other flows, and these are defined by the hospital, they define 5 important flows. This is when you have an appointment, and this is when there is an emergency, so you don't have an appointment. And if you now look again as this system as a section again, so here is the polyclinic, this is the clinic where the beds are, this is when you have an appointment, and this is the acute column, and the diagnostic, that's for instance radiology. And then on top of this patchwork, and this is then the ground floor, we put on all the different parts of the brief. So we have the operation complex, we have cardio center, all these kind of functions are all put in the right position. And this one all along was a very interesting process together with all the doctors and nurses, because they have to define where they were in the process. The next step was, how is this one connected to that one? It should be close by, or it can be a little bit far away, or is it very important? And each of the flow of people, flow of value stream we call it, where medical sitting out of 15 doctors, and altogether they have to decide which is the most important connection. And that's where all those, these, how do you call it? Sonics. This little attention point is our priorities in which connections are the most important. And from there on we start to design the floor plans, because now it makes sense what should be next to what, all in, and always keeping in mind what is the best for the patient. This was a way to organize the project, and of course we discussed it many times, and that's what architecture is also about for me. It's listening and understanding. We were lucky because we didn't design a hospital before, so we can always ask, why are you doing this? Can it be done differently? And they kept on explaining to us how it could be different or what should be definitely the same. And then next step is also in a lean designing process, eliminating waste, was that from the floor plans we designed then, we start building it in cardboard. So we hired students to do it in the weekends. Sorry. In the weekends they build it up, and then during the week, each department of the hospital, together with doctors and nurses, they got in together with their patients in testing the department. Then next weekend, new students, new mock-ups, and then we did for weeks after it started. And what was really good to do here, with testing things, because by then even we, of course, we believe that we can read the drawing and we know how to turn around with a wheelchair and we know how to move with the bed. Well, to be honest, also we made some mistakes, so we had to change things, of course, and it's best to change it now instead of then when everything is built. But of course, the doctors and the nurses, they also had to really, oh my God, this is not the way to do it. Hey, we have another desk here and another desk there. Why not combine them? It's much easier for the patients. So we did a lot of changes afterwards in the design. We did the workshops, and they call it the 7 flow workshops. Somebody from America who was really the lean expert, he came over and took us through the process how to organize that. So altogether with the cardboard models and the drawings, we did the 7 flow workshops. So each of this line is supposed to be a flow of either family, patients, but also medication, information, all kinds of flows which were necessary for this process. We're taking into this drawing. So this is a really small part of the building. Huh? So we did it for every part of the building. And yeah, it was a good learning process. And I hope we prevent a lot of mistakes in the building. So then we end up with, again, floor plans, and then you go to the next phase and then you build in the typical rooms and you build them out of wood instead of cardboard, and therefore you can introduce the beds and the wheelchairs and the testing room. Well, that for us is also really about making an architect, testing it yourself, experience how it is to be in bed, to look into lights, to which you don't want, or to travel all the way to the operation room while you are nervous for the operation. What do you want to see, what you don't want to see. And then the last project, the Sporthogeschool in Eindhoven. It's 16,000 square meters, and it's in Henneke Parken. This is the render, and this is the building, how it is now. And it's in the Henneke Parken. So we're here now. This is the Henneke Parken. Probably you've been there. It's a huge sport area where if you zoom in, you have all these, you have a lot of sports that you can actually do there. And in this part there will be, this part is, there's this new, well, it's not new anymore, it's 4 years there now, Sporthogeschool. So Sporthogeschool, how to translate, it's a sports university, I guess, sport college. And that's for architects, of course, a lot of fun to do because it's a very dynamic school, because it's a lot of learning environment, all around it interesting, but then combined with sports makes it really fun to do. We said in this area of trees, and it should also be a social, safe building. And we want to make a network of all those sport facilities. But there's one problem. The sport facilities in this project were actually closed boxes because of the NRC and the Olympic regulations. You cannot have daylight in your sport facilities. It's pity, but that's the way it is. So it should be closed boxes. So how to make open and transparent building for us then was not to put the two things next to each other, but put the two things on top of each other. So the school could of course be more glass and more open, and sports facilities were more closed. Therefore we could make connection to the outside. So at the same time we asked the Sporthogeschool, please make one of your sports facilities an exception to all the other rooms. So we could make one sport hall with light from above. We put it in the center of the building and we lowered it from our concept of the first level. We lowered it to the ground floor again. And I'll show you why later. Then of course we had this transparent plinth, and then we were lucky we could also got to make a climbing wall, so that makes also a nice tower on top of it. So this was the idea: skull in glass on the ground floor, sport in the top, and then we start of course mixing a little bit. This is the whole building, and then we take off the roofs, and you can see the sport facility here. And these are actually three big sport rooms all together, let's say. And this has 400 tribune for 400 people. And here you can see already the skylights for this room, this sport hall in the middle. Here you can see the sport hall in the middle, which we lowered again to the ground floor. And if you talk about from concept to realization, it's easy to draw it. It's a line, and then the sport is going up. But then if you have to do sport on the top, of course you start to play basketball, you have to take a lot of acoustic measurements to actually be able to do so. So it's actually a box-in-box system what we had to make here. And this is the lowest floor, the ground floor on the plinth with the restaurant to the south. Here's the Eindhoven Stadium, and this is the Mediatheek and the offices. And when you come in, you can actually look through this room to the restaurant, and then again see outside. And our idea was to, on the ground floor, there were also changing rooms, how to make it still transparent, because changing rooms are of course without windows. We said we put the changing room slightly in, we give it a big bright color, because otherwise glass is not so transparent, so it becomes transparent when you put light or a color behind it. And this is the way how we in the end organize the lockers in the walls of the dressing rooms. And then from the outside it actually becomes quite transparent. And then here you can see this huge, big closed box of sports facilities. And then making architecture is also about convincing people. Because we had a supervisor and he said, no, it should be white, all the buildings should be white in here. We go, oh my God, how it should be white? And we tried to convince them because we wanted to have this transparent plinth, and it is a lot more contrast when it's in a darker color. And the other reason was, I think I showed more or less 3 white buildings before. I love white buildings, but in this case it's in a very green environment, and white brick really becomes very fast also green then. So we said no, it definitely should be a dark building, and he was talking about contrast. So we started to take our panels everywhere to show even with shadows there's a lot of contrast also in the black building. So finally, luckily it became a black building, and the next thing we did was try to make the building really special, and this really big blind facade a little bit more attractive. So we made in the brickwork, we put the bricks a little bit out from each other, and then we made sport icons in the brickwork. This is actually within this sport hall in the middle. I don't know where they made it, but this is where they tested the room, the brickwork. And this is how it worked out really beautifully in the sun. So this is the climbing wall. This was one of our first design sketches about a room in the middle. We thought it's very important to have it transparent all around on the first floor. And then have a sort of wooden box where it's actually sunken down. And here, all the glass around. It was also a big fight to get it in the end because, of course, it's going over the 1,000 square meters of fire compartments and it's not a sprinkler building. So in the end, all this glass is fire proof or persistent. And also these doors, normally they close down when there's fire somewhere, and they're also made out of glass. So, but I think it works very well, and I was just there, and they still use it the way we think it should be used. And we had a big discussion in the beginning also with teachers, because they thought, okay, but then my students are visible. We said, yes, it's very nice, it's a sports educational building, so it's very nice. No, but then when they do things like this, when they make trampolines or what they do their very difficult tricks, then they're being looked at, and maybe it's more stress, and then they cannot do it anymore. And a few weeks ago, I met some of those teachers, which were in the beginning a little bit reluctant, and they're really happy about it. Actually, it's working the other way around. People are showing off, and they're doing really good. They're really doing well. I show you some pictures how this room is working. It's a lot of light coming in the center of the building. We were always also able to design all the furniture. It's also quite fun to do because people, the students are actually physically, they're laying down with their laptops and not actually sitting in a chair. It's very, very good. This is how it works in this central room, and there's also study spaces all around the space. This is the restaurant where we integrated table football in the room, so you can actually look in this big room again. This is how they use the space, bikes, and we're on the first floor here. And now we look this is where you enter the building, you look in those big room, and you can be able to look out the climbing wall. From the sport halls, you can also look again back into the people studying. And this is, of course, an actor Sonderland was invited to do his exercise there. Then, of course, students start to gather around in this glass and corridor around. And in the end, that looks like this. So it was for me a really great moment where I thought, yes, it's working the way we want. And the last thing I would like to tell you about making architecture is about teamwork, because you never do it alone. It's always with a lot of people. You should have fun with your clients, a little bit formal fun. You invited the client first to go to Birmingham, or with your design team, and then having a little bit more informal fun. But I think it's important you do it always together. Thank you.
I would like to kick off with the first question to you. What struck me is that in the last 10, 20 years, also in our office, a huge change has come true by expanding the way to the foreign countries, Asia, United States, etc. But there seems to be still a very consistent identity to the building. And in how far does actually the building and the making of the building change while the world is growing, where the world where you build with different techniques, different ways of building. So is that influencing actually the way that you are building in Holland? So is there a reciprocity in the way you are actually making the architecture?
Yes, very much, of course. Yeah, the work you do in other cultures, in other cities, influences, of course, the work you do in Holland, and the other way around. And
what are the major? How do you see the major changes? So what is?
yeah, I think it's more about the attitude that changes towards how to work as an architect. It's not actually maybe a technique, although, for instance, in the project in Taiwan, I don't know, maybe you know the big. It's all three-dimensional shapes, something we don't do so much. But there we did it for a very good reason. But we invited the shipyard industry to make the three-dimensional facade, something it's a Dutch a company who's actually building ships there in Taiwan. So it's of course you do the cross cross interventions. Yeah, you use it a lot. But on the other way, in Taiwan, it's always warm and wet, so you design a totally different kind of building, which is, for instance, totally open instead of where we have to put a facade here. So it has differences, and it has.
Does it have also more possibilities? No climate problems.
Yeah, of course it has possibilities. I don't think we should make a steel shipyard facade in the Netherlands. After a few years, I don't know how good it is.
Hey, René, I was really struck by this this idea of the waste and the foam. You are actually making buildings like we are making models in our office. So, but how in this process of experimentation also very much, so how do you deal with the link between experiment and reality? So you are of course confronted with fire regulations, acoustics, the forces, so you are experimenting with the material, but that has also a lot of risks for your client, but also of how you have to deal with it. So how do you work with that?
Actually, in all the projects we do, we have those risks. It's also when you look at the Archon building, so it's one of the buildings I showed in the beginning. Yeah, they couldn't bend a panel like that before. So actually they could bend 3 meters, and they say, oh, we have to bend 60 centimeters. And I said, just do it, and if it doesn't work, you try it again. And in the end, they find a special alloy to do so. But we already had it in our contract. So the problem is you go to a client, with the Archon building, we went to the company who built those panels and said, we can't do it. I said, yeah, you can do it. And you explain them how to do it. The funny thing is I built my own house, which you learn a lot, and you can really tell the client or tell a contractor, if you do it that and that way, and they believe you. And that happens. So when we got the contract, we let him sign that he can build it. And then we had the tender, and then he signed it, and afterwards all the departments said, no, we can't do it. And then they built the whole thing. And then halfway the building, there became a big bump in the building. And they said, see, we can't do it. And then they put the walls at that time on the site, and the walls to every panel separately, and they could do it. So it is really difficult. Every project you have to get your materials, and every project you have to work separately with your subcontractors and your contractors. And every project you have, somebody who says, we can't do it. We don't guarantee.
But how does this relate to craftsmanship? I was struck by the fact that you said in the beginning that with the composite that you learn, that in the next project you learn. Do you have this kind of craftsmanship development that you learn throughout the different buildings that you improve or that you test? Or is it every time another thing and testing it again and again?
It depends on, we have a big variety on projects. So that means that it comes from bridges to, for instance, the last bridge, they never built that before, so they don't know. So that is a risk, but yeah, we have an insurance now for 25 years, we never used it. So we're probably the only company who makes those things. We don't have to use it because in the end it always works out. You find a way that it works.
Does that also have to do with scale? So like the chapel you showed, are you testing it first on a small scale so that, or would you also build a 30,000 square meter building with the same material?
If you build a 30,000 square meters, you have to be sure. That's the nice thing about small scale is that you can afford more. Because yeah, if it doesn't work, then they're they're always happy to build it. And if you're a huge building, then the money, then it is a problem. But even with the bigger buildings, with Block 16, we didn't have that problem. I told them that you just can have a panel and just flip it in. And then the contractor came, yeah, you could just flip it in. And that's how it works.
From the audience, I know that a lot of people have a lot of questions, so who can I get the microphone as first?
René, you have experimented with 3D printing and you have experimented with foam cutting. Have you thought about a combination of the both? Like a 3D printer that prints foam?
No. The biggest problem with a 3D printer at the moment is that it goes very slow. So it takes really a long time to print something. And if you can't speed up the speed of the printer, it's not going to be valuable in the future. It has to speed up. And all the experiments you see, they make the steel bridges. They're, yeah, how do I say, more or less not that Italian. So if you need welding rod to build your bridge, then first it takes a long time, but then the quality is really bad. And with the foam cutting, that was the only technique we could find which is really useful.
Okay, clear, thank you.
I always have questions, right?
Yes. So, Adam, I was wondering, you thought acoustics is very important for buildings, that cozy feeling even in a large building. But how did you accomplish that in the Hilton Hotel? Because it was quite hard to see any...
Sorry, I forgot to tell. Every white you saw, so it's all those, right?
Yeah.
It's all acoustic material.
Okay.
Everything, so it's acoustic plaster.
Okay. Yeah. That's it.
And you need that amount of acoustic material to really make it nice. Yeah.
Okay. Yeah, thank you.
Sorry about it. It's very important.
I'm a bit far away, but
Maybe you scream.
I think everyone here would like to be where you both are now as a successful architect. What are some tips or what do you think is important to focus on in now as a student?
say just do what you really like to do. And yeah, that's true, have fun. Because if it becomes work, you should stop.
Can I say?
There was another question here somewhere. You can also.
Yeah, I have a question for Alan, because you said at the end that also making architecture is about having fun. I know from my education that it sometimes also can be very frustrating, especially when, for example, the Hilton project, that it was cancelled twice. What I would really like to know is what did you enjoy the most from your projects?
And maybe that has something to do with the question you were asking in the back. The hospital project, because that was something I never done before, anything like that, and then I think it's so much fun to do when you really don't know, and then you try to find out, listening, try to be the patient, try to be the doctor, try to understand all those magically words I never heard of, and then slowly finding out. And then finding also out that people actually appreciate your opinion because you know something else. And then the synergy between the two is very, very nice. It's a lot of fun. And because of the complexity, it's a lot of fun. For me, complexity is really nice.
That's it.
Okay, with a nice conclusion. Are there more questions? Oh, there is still. Oh, now suddenly all kind of questions. Can I ask you to yell?
Well, I want to ask a question for both of you. Then, have you ever think about combine the architecture with the culture of that country? Because I can see that buildings that you build here and in other countries they are similar. So, well, I assume that some buildings should have some cultural identity. So, did you think about that?
Don't know if I understand your question. Did you?
If building in different countries does have a different identity. So if you build in Holland or if you build in the United States, if the buildings have different identities.
Yeah, for the culture of the local.
Yeah, absolutely. But I think also the projects I was showing are all are totally different. So it's not only the culture of a country, but it's also the culture of an organization or the city where it is. But indeed, if you go, like we were just briefly mentioning, Taiwan is of course a totally different culture and a different building. Yeah. So the common thing, as we like to see it within Meccano, is the attitude towards the projects, the attitude towards the people who are actually going to use the building, to try to understand what they need, what they want.
There was another question up there. Yeah.
Yes, I want to ask Anna, because actually I'm from Taiwan and it's very interesting to hear you are talking about a project in Taiwan. I was wondering, when you are designing the electronic in Taiwan, have you ever considered like the local climate and also the local materials into your design? Yeah, and also like because Taiwan has a lot of earthquakes, you also consider
Yeah.
And how did you apply to it?
Well, to be honest, the project in Taiwan is not my project, so I do not do myself, but of course the whole office is looking towards that project because it's immensely big. It's 140,000 square meters. It went through all wind tunnelings because you have not only earthquakes but also thunderstorms, hurricanes, and all, so everything is tested. Also, the acoustics are tested in partly one-to-one models. So it's a very important or interesting project. And you were asking about materials. The whole, yeah, it's a pity. Maybe I can talk a little bit about that project. The concept is based on banyan trees, which you have lots. And those banyan trees, they grow not only on top of the ground into each other, but also underneath the ground. They grow into each other. So the space that's left behind is the public space. You use it in parks. A lot of people use it as to relax, to sport underneath those trees. So we made a building in the shape of those trees. That's why we have this shape. Normally we don't have such a amorph shape, but in this case we have, because we're following the trees. And the public space underneath is then the foyer space for the theaters. So yes, we try to integrate on all levels also the culture and the flora, fauna, the climate of the countries, yes. Next time I will come here. More about it.
Okay,
one question for Ellen. Because of the hospital, you were also using this kind of prototype with the cardboard and later on with wood panels as a design tool. But I was wondering, is it just for measurements of how wide the corridor should be, or
No. Actually, no, that was the thing that struck me the most, because I thought we had it all under control, and sometimes at some corners we didn't. No, the hospital, the people, the doctors, the team of the doctors, with their patients, they went in to see how the flow of entering the building, the waiting area, everything. So, for instance, in the dialyse, I don't know the English word, dialyse afdeling, there was some of these people are rather big. So then they were testing how to weight their people, and then the patients, actually the actual patients of the hospital, they also came into this construction hall, and then they came into and they helped also testing. They came in with their wheelchairs. It was really good. So they were totally focusing on totally different kind of things than I was focusing on. That makes it so good to test it on all different levels.
And in what way did the design develop the most?
I think there was still a lot of waste in space. When people start making their own brief, because every department in the hospital makes their own brief, so we have this dialyse, for instance, they just write down, okay, we need so many that, so many this, so many that, and then you all count up, and there it is. Then we do the bruto netto, so we have corridors, we have toilets, we have columns, and then you end up with quite some space. And the next department will do the same, but sometimes you can share things. And that's something that that in a hospital which is so big, but then sometimes you don't see that's easy to share. Maybe the front desk. That's what happens, for instance, they start to share spaces. But for instance, another thing is PIC cabines where people they give blood. They were very small, because at that point they designed sort of chairs where if you start to faint, you can actually smoothly lie down, and they had new, well, just new chairs for that. And the chairs were just half a meter bigger. So we had to redo that, and it's better to redo it in carpet than in the real building.
Ja, nou zeg nog niet.
How do you deal in the hospital project with with future changes when you test it in the specific way that you tested the project? How does the project deal with the changes? So what happens if the chair
becomes bigger
even
again?
bigger?
Yeah. Yeah, that of course you never can prevent changes in care. They told me it's probably quite normal that after a few weeks of opening they start to rebuild a few of those things again, but at a bigger scale, it's always something to take care of. Next to the hospital, we designed also the Zuuk Boulevard, which is actually all the functions that are not necessary to have it in the hospital anymore. They are in the building next door. They're all connected in the inside. So for instance, there's a zorghotel. So that means that the amount of beds in the hospital is sort of doubled by the fact that there is a zorghotel next to it. The restaurant is not in the hospital anymore, but it's in the zorgboulevard. It's all indoors connected. But that means that there's a lot of flexibility and you can move functions around in the future. The hospital can actually grow into the zorgboulevard. And then the other part, of course, how to shrink. That's also an assignment. What happens if the hospital got smaller? So therefore, we designed sort of phasing in the project. So and we chose a grid which is actually usable also for more polyclinic-achtige functions in one part of it. Of course, the core, where the emergency column, let's say, is, will always stay the same. So you can never go from 8 operation rooms into 4. Then you have to do a really big renovation, let's say.
Thank you.
I've got a question. I got a question for René. You were quite disappointed actually at the building in China that they printed 3D. And of course it has to do with technical problems, like it's just a 2D form you can print and extrude. And also you mentioned the problem of the goes very slow. So do you still believe it's the future of 3D printing and printing houses?
I think that's a future in 3D printing in the future, yes. Because I think the techniques will differ, will change. And it's changing everywhere. Nowadays, the 3D printing is very good for prototyping. I mean, if you have a Volkswagen, you don't want to 3D print your engine because you need 100,000 of them. But if you have a Formula 1 car, yes, you would like to 3D print that one because you have a one-off. It will be very difficult to build that one. And I think the same, what we do in houses is more like we make prototypes every day. So yes, 3D printing could be very well, work very well for that. But yeah, if you make social housing and you make thousands of systems where you can have molds and you can have other techniques which go faster. So yes, most of the time, something never replaces something else. We still use a hammer. We don't use old pneumatic hammers to drill a nail in. But yes, there's something in addition, and if that something in addition can make the architecture we can't make it in a computer now, but we can't make it in real life now.
Nou, roep maar gewoon.
Well, I have a question for Alan. I've seen all of your projects are also pretty unique. Do you think 3D printing is the future?
Yeah, too big now. No, I think for the facade elements of, for instance, urges, that would be a very, if that would be printable, it would be really make sense. And I think maybe the printing machine is not there, but the thinking behind it is already there, because we do everything in a computer. So actually we do the 3D printing of our models. We do it all in 3D printing in our office. So there's one structural engineer, we work with them also, ABT. They say if you can make it in a model, you can make it for real. So in the end, I think it would be smart thing to do.
I think the beeld en geluid is, the glass is 3D printed.
No.
It's made in sound.
Yeah, no, it's not 3D printed.
That's more or less, you have the sound you used,
Yeah,
and
yeah,
they glue glass, so you already can use it for facade.
yeah.
But in a different way than a normal 3D print is.
Okay, I would like to thank you both very much for your inspiring lectures and for nice discussion afterwards. I would like to do a small notification for the upcoming lectures, because we are now at the third and we have 2 more to go. There will be a small alteration in the next lecture and we will keep you informed. So they will be super interesting, with again super interesting architects coming to speak here, but check the website, check the Facebook page, and we'll inform you as soon as possible. So for now, all have a very good night and a very good evening, and thank you very much.